the synthesis product for ocean time series was firstly probably written down as an outcome, as an actual outcome of the data time series workshop we had in Hawaii, so when I was introduced. And since then I had the opportunity to lead the pilot for this vision. And I think, as also Heather has mentioned, that the pilot is quite a nice use case for this community when it comes to thinking of the challenges, but also the benefits of the time series community working towards more fair data. But before starting, I first of all want to thank all the 12 participants, which you can already see here in this title map. Some of you are actually in the room, some of you are online. So thank you very much for participating, for providing your data and supporting and giving the expertise that made this pilot possible in the very first place. So I want to start with some background of why the vision spots has actually emerged in the first place. And I think all of us in this room here can agree that time series are one of the most powerful vehicles for monitoring marine ecosystem changes, and that this observational platform more or less occupies a very unique position in the space frequency domain compared to other observing platforms. And when we think of the collective value of this community, so when in particular think of joint time series study, they have huge advantage compared to other observing networks when it comes to when it comes to enabling differentiation between natural variability and anthropogenic driven events. And there are some products, there are some one-off joint time series studies, many of them actually, who have proven the benefits of this joint time series approach, where you compare trends across several sites. One of the most prominent one, I guess, is from Beta. It's almost a decade ago now. Here an example shown in the upper right, where you can see the trend comparisons across 8 different time series stations from around the globe, where for this example here shown are the surface PSU2 concentrations in time. However, despite the success of those joint time series studies, we still think that the impact of the community as a whole on a global scale in scientific reporting and global assessments is limited. And that has to do with mainly 2 things I've said. First of all, these one-off joint time series studies, as one here shown from Beta, before actually doing the trend comparisons, they first had to deal with a lot of manual data work before being able to do the actual science. The data work links to the collection of the data, harmonization of the data, and to assure that actually apples are compared with apples and not with oranges. You want to think of low-level nutrients and just regular nutrients, for example. So that's one case, one reason, which also links to the reproducibility of the results. I mean, every time such a study has to be performed, the exact same work has to be done again. The second thing is, and that's a bit highlighted here by the map shown by Ignace, where you'll hear more from I think tomorrow, where you can see all these blue dots representing active ship-based time series stations around the globe. And you can imagine that for a single joint time series study, for a single research team to collect all these data from all these different stations every time and time again you do another joint time series study, it's just too many, so it's not scalable. So the scalability becomes an issue. And that's why the collective value of this community, we think, is not sustainably exploited. And that's where the idea for synthesis products come into play. And synthesis products have shown their benefits and how they deal with that issue for other communities as well. I mean, you can think of the Global Ocean Data Analysis Project, GODAP, for the GoShip community. You can think of SOCAT to serve CO2 atlas for the SOCONET community. And what these synthesis products do is they take care of that manual related, data related work for the scientists. So take the burden off of the scientists. So they take care of the collection, they take care of the harmonization and formatting, the archival, and if needed, quality control data integration, and of course then the eventual product provision. Depending on what source they try to integrate, customized techniques have to be applied. So clearly, GODAP applies different techniques than these are needed for this very community. But all of these synthesis products have in common that they try to work towards fair data, also open data. I know that open is a very hot topic, but synthesis products are open data, and also to work towards comparable data. Fair and comparable data are very much interlinked, I still put them here separately, but when thinking of Danny's introduction to FAIR, that you saw rich metadata was one of the points that links to also with the usability of the data. And that's where rich metadata is very important for the comparability of the data. And by doing that work for the community, the synthesis products in the data value chain pyramid to connect the individual observations with the higher level societal services. This provides this present gap that there still is in this community to be more effective and more visible on a global scale. So for the pilot, that's on the right-hand side shown here, we then had to figure out how to do this for the time series community. And we had 3 building blocks: standardization, quality assessment, and provision. So standardization links to collecting the data, mapping them to control vocabularies. I've heard the term now many times. It's very important when it comes to fairness of data. Also linking to conversion of the units so that they're all common. And if possible, creating the missing metadata information from the past. So that is very much tied to more fair data. Then the second building block is quality assessment. And here that is very much tied to comparability of the data. So there are different ways of how to achieve this. Ideally, every center would just come with an uncertainty assignment or uncertainty indication. However, we are far from that. So you can either do some statistics on it. Eventually, we applied several types that indicate how far the different time series are comparable within one another and across one another. The one we put most emphasis on was what we call the standard operating procedure assessment, but more on this later. And the last part here is then the provision block, where the actual product generation is taking place, so the merging of the individual data sets. We then also link to ODIS so that at least for spots for the pilot that focus on ship-based time series data and biogeochemical data only is now already this hub within ODIS. And of course, also we link to our data repository that was BPDemo. They also helped us out a lot and are the place where you can access the data, and also enabled us to link to ERDAP services so that the formats are already interchangeable. So again, increasing the interoperability of the data. I want to have, just taking 1 minute to mention a few hiccups when it comes to the collection of the data. And you can also see a bit more details on the participating sites. Because you might think that the collection of the data is a very trivial thing, the easiest step of them all. So what you can see here are the 12 participating sites. The shading indicates to which subbasin they belong to, and then you have some higher level metadata information for showing the characteristics of the different sites. And for the pilot, we actually try to have a very heterogeneous set of time series included to be as representative as possible of the entire community. So we have different time ranges, we have different temporal resolutions, we have coastal stations, deep ocean stations, we have stations where there are dedicated vessels going every time to each station visit, and other stations where they just make use of some research cruises that just pass along. So the thing with the collection is, and I think that has already become clear during the past talks, even though many of the participating sites already had data archived somewhere with some DOI, in some cases we had multiple DOIs, in some cases we had data that was QC'd that was not QC'd, in some cases we had data that did not have a DOI. And so you really need to be careful which data you pick. And so even such a trivial thing as the collection is not that easy. And that is for 12 sites, manually possible, yes, no question, even for one of joint time series study. But if we think of the scalability, if we think of, I don't know, tens and maybe hundreds of stations, that suddenly becomes an issue. And that's also why it's so important to have these fair data. Another thing I want to go into a bit more detail, but I'll have another talk where I focus more on that. So I'm just going to really roughly touch upon it. Is our main method that we use to achieve these, to achieve an indication for the comparability of the data. That's this SOP assessment. So what we've done here is we tried to compare the methods that have been applied for each dating visit of each of the participating sites. And we compared these methods to the standard operating procedures that were out there. And the left gray box here shows you the source we used for the SOPs. Main source was actually the Bermuda time series workshop from 2012, so more than a decade ago. But other sources have been used as well, and that's why the pilot was also so important to have all the knowledge from the participating sites around. And eventually we came up, that's now just part of it, with such a table here shown on the right-hand side, which are grouping the SOPs into required and desired blocks for the different BGC parameters. And again, we're going to show an example of this in my next talk, but what I want to say here already is this is only possible with proper filled out rich metadata. And that's also why one of the results of the pilot is actually that BGC pilot, BGC ship-based metadata template. I'm going to finish off with just some quick facts about the pilot. So as I said, actually 2024 that was the first planned date for this workshop, so it's not 2025. I didn't update it. Sorry, Adam. So we have included 12 time series data in the pilot with, as I said, varying temporal resolutions, varying time ranges, varying bottom depths. We have more than 100,000 water records already included, with the oldest sample being from 1983 and the newest one from 2021. And as I said, we have focus on ship-based time series and biogeochemical essential ocean variables, which are listed here in the bottom. With the pilot, we already have proven that we can help to support the individual sites to become more fair. We have spots now as a node of orders. And through the combination of multiple assessments, we have increased the intra and interstation comparability. Again, the main one that we relied upon was that SOP assessment, but what it was accompanied by more statistical approaches as well. And when thinking of the METS community becoming part of becoming an observation network under the GOOSE umbrella, at least partly with the help of this pilot, it has now been achieved that the METS community is seen as an OCG potential new network. So good work still has to be done so that we are fully recognized under the GOOSE umbrella, and that we eventually could also then be part of the GOOSE hypernode in OTIS, but these steps are taken towards this as well. For the outlook, I also don't want to go too much into detail now because we have a dedicated spot session, a breakout session on Thursday, where I want to discuss or hear your feedback first of all, discuss pros and cons of the spots vision, and also discuss possible future scenarios for spots. Of course, in my head, one of the biggest things would be to reach a critical mass so that proper spots could have proper impact within the community. It goes beyond just 12 sites. Also, I want to say that we've already shown what can you how spots the pilot can be used. We, for example, used a trend analysis tool developed by Adrian Sutton, which he'll also talk about, and we've not only implemented it in OTIS, but also the ODV viewer has used spots data, and Sebastian is going to say more about that on Thursday as well. And with that, some links are shown here where you can actually download the data, and the paper is also linked, I think. Yeah, thanks, and coffee break. Or maybe questions.
Nico, could you leave that slide up just while people go to break so they
Sure.
can find that? And I did put Nico's paper in the folder where you want to access. Any questions?
I have one. I'll just keep it later. So how can we include different time series? How was the issue? How can we tackle the gap? Because sometimes it's another thing. Sometimes we think that our gaps doesn't prevent us to share the data. That's why we don't contribute to a lot of effort. And sometimes we need to stop analyzing that.
So two things there. First of all, I hope in the future we have a world where we truly have submit once use many times, so that when you submit somewhere, you don't have to submit to spots in particular, just state in the first submission whether you would be open to providing your data or not. So that would take a bit of burden off there on the submission itself. And then when it comes to the gaps in the past, well, the metadata information to gather that, also historical sense, I can't do that for you. I have to admit that. Of course, we will support you as much as possible, but the actual collection of the metadata, that's up to the data provider. And as Kim has already mentioned, that's a huge amount of effort. But that should not discourage you from joining such efforts, because even if you can't close these gaps, first of all, still you increase the visibility of the data, and we just have an indication. Well, we're not sure how compelled your data are, but still at least we have them, and we have the according with the indication of it. And then from that point on, you have the templates you filled out, and at least for the future, all your data have no gaps when it comes to the metadata, which hopefully going up the time. But again, that so gaps shouldn't discourage you from joining such efforts. And the important part is that we have a column that indicates how far your data are compelled to, or fit for the purpose. And I mean, fit for the purpose is an important sentence here, because for some, it might then not fit it because you don't have metadata information. But for others, it still could be very useful. Yeah.
Yeah, sort of picking up on that. Yeah, one of our sort of mantras with Otis is just share now. It's okay if it's small, right? Because as Nico said, with the fitness for purpose thing, a modeler might just need that one measurement that you took, right? It could be in your metadata or something, but that could ground truth the model that they can then improve. So never be shy about it, even if it's not complete. It's like that positive publication bias in biomedicine, right? So much information is just not shared because it didn't work. But that's we can't think like that anymore. It's useful to somebody, or it could be, right? Your metadata may be somebody else's primary data. So we have the architectures now, we have the systems. Nico has figured out the model. And I think this model can be the model for that time series hub in Otis, because the synthesis data product is basically the plumbing, the near surface plumbing for that portal. I think it's getting close.
I think a big topic here is then, and we're going to have this discussion after the break, is open versus non-open data, and that's a very personal thing, of course, but that's where we see how the discussion goes next.